Hello student, in this video I am going to explain to you how to solve a non-linear partial differential equation of first order which is of type 3 or standard tree. So now this standard tree involves only three variables set p and q. So a function of which a function f which has only the variable set p and q can be solved by this method. So let us see how to solve an equation of the form f set p q is equal to 0 in general. So now the first step what you need to do is you put, if you have an equation involved only set p q, then in that case the first step you need to do is you put capital X is equal to small x plus ay, and assume this set here to be a function of x plus ay, that is set will be a function of capital X. Now therefore you can write this set as f of capital X, where what is capital X? It is x plus ay. So we denote this as equation 1. Now what is P? P stands for del set del X. This one in the beginning we have given you the notation del set del X. Now since set is a function of X, so I can express this one as del set del capital X into del X del small x. So del set del small x can be written as del set del X, differentiate set with respect to capital X and then capital X with respect to small x. But what is this one? Del x del small x is equal to what? If you differentiate this equation 1 with respect to small x, then del x del small x will give you 1. So it will be 1 here, and then finally what is small p? It will be del set del capital X. Similarly, what is cubed? Cubed is del set del small y. But now since z is a function of x, so you can express this one as del z del capital X into the differentiation of capital X, the partial derivative of x with respect to small y, so del y. Now what is del x del y? From equation 1, del x del y is equal to what? If this part will be 0 and differentiation of y with respect to y will be 1, so you'll get a. So you have it as a. So finally cubed will be equal to a into del z del capital X. Now you see that since z acts as a function of just a single variable capital X, so in place of del z del x we can replace this p small p by d z dx, which is an ordinary differential equation. And similarly for cubed also, because we have del z del capital X, so we replace this del z del capital X by d z dx. So cubed will be a d z dx. Therefore you substitute the value of p and cubed in this original equation star, so that it will become f of z dz dx a dz dx, and this one you'll see that it is an ordinary differential equation of first order and can be solved easily, like what you have done in for the case of first order ordinary differential equation in first semester. Now I'm giving you this remark: sometimes change of variables can be employed to reduce it to standard 3. Now like what we have done in standard 1 and standard 2 also, there are some problems which are reducible to standard 1, standard 2. Here also there are problems where not only not only set p q are involved in the given function, but the x and y variable also may be there, but we can also reduce that one to standard 3. So by a proper substitution, then we can reduce it to standard 3. So I'll discuss that one in detail in the problem. So now let me solve first this problem, which is already of the form f p cubed set, where there are only the three variable p cubed and set involved here. So solve p square set square plus cubed square is equal to 1. So you can write here solution given p square set square plus cubed square is equal to 1. Name it as equation 1, which is of the form fp cubed set is equal to 0, that is of standard 3. Now for this one you put capital X is equal to x plus ay, and this will imply what is del x small x? It will be equal to 1. Del x del small y is equal to a. Now what is p? P is equal to del straight away I'll write that one. It will be dz dx, and cubed is equal to what? It is a dz dx. Now let us substitute the value of p and cubed in equation 1. P is equal to dz dx, cubed is equal to a dz d capital X in equation 1, we have, it will be d set dx capital X the whole square into set square plus what is cube? It is a d set dx the whole square is equal to 1. Simplify this one. What is a common term here? D set dx. So d set dx the whole square is common. Then it will be set square plus, now here we'll get a square. This is equal to 1. Or d set into, okay, if I take the positive square, or I can transfer this one to that side. So d set the whole square into set square plus a square. This is equal to dx whole square. So taking the positive square root of this one, then you'll get d set into square root of set square plus a square equal to dx. Or square root of set square plus a square d set is equal to dx, where the z variable has been separated and the x variable also has been separated. And this is a standard integral. What is the integral of square root of square root of z square plus a square d z? It is this formula. So on integrating this one, you'll get it as square root of z square plus a square by 2 plus a square by 2 sine hyperbolic inverse of z by a. And this side it is capital X plus some constant k. So finally, what will be the solution? It will be z square plus a square by 2 plus a square by 2 sine inverse of a sine hyperbolic inverse of z by a. See, on integrating this one, since it is a standard integral, so integral of z square plus a square dz will give you square root z square plus a square by 2 plus a square by 2 sine hyperbolic inverse of z by a is equal to, this side integral of dx will be capital X plus some constant. So this will be z by a here equal to, what is capital X? You replace back the value of this capital X by that one. We put capital X is equal to x plus ay plus k. So this is the required solution. Now let me come to the next problem, which is not of the form f p cubed set, but we can reduce it to that form. So let us solve this problem. P cubed is equal to x to the power 4 y cubed into z square. So first of all, what I need to do now, transfer this x to the power 4 y cubed to this side and keep a z square to the right hand side. So solution will be given p cubed is equal to x to the power 4 y cubed z square. Or what is p? P cubed by x to the power 4 y cubed. You can write this is equal to z square. Or I can write as p by x to the power 4 and cubed by y cubed is equal to z square. Now what is p? P is that del z del x. Because this one is not of the form fp cubed set, we have to reduce it to that one first. So let us simplify it by proper substitution to reduce it to that form. So now here, what is small p? It is del z del x. So it will be 1 by x to the power 4 into del z del x into 1 by y cubed. What is cubed? It is del z del small y is equal to z square. Or now it will be del z by x to the power 4 into del x into del z, numerator remain the same here and here. This is y cubed del y is equal to z square. Now by proper substitution for this one and this one, we can reduce it to the form fp cubed set is equal to 0. So here what you need to do is, this del set here, the coefficient of del set is here 1 1. So we need not change this one, but for this one only, x to the power 4 del x and y cubed del y, we have to put a proper substitution so that it will reduce to that form. P cubed is equal to z square. So now you put x to the power 4 del x is equal to del capital X here. Then this will implies what? X to the power 5 by 5 is equal to capital X. Let us name this as equation 1. Name this as equation star. And then y cubed del y, you replace it by del capital Y, and this will implies what? It will be y to the power 4 by 4 is equal to capital Y. Now equation 2. Now substitute it in this equation star. So therefore equation star now will implies what? It will be del set. Now for x to the power 4 del x, you replace it by del capital X. Then here del set will remain as it is, but y cube del y has been replaced by del capital Y. So this is equal to set square. Now you put capital P is equal to del set del capital X, and capital Q is equal to del set del capital Y. Now name this one as equation 3. Therefore equation 3 now will implies that P cube is equal to set square, which is of the form Fp cubed set is equal to 0. So it reduces to this standard 3. But now here what is P? It is del set del capital X, and Q is del set del Y. But now if it is of this type, then we have to put that one. You put that substitution, but we cannot keep that capital X is equal to AX plus Y anymore here, because I have already have this X substituted this one. X to the power 4 del x is equal to del capital X. So let us take it as this one. U is equal, and in place of small x and small y, in this case we have it as capital X and capital Y. So U is equal to A capital X plus capital Y. Then this will implies that del U del capital X, capital X plus AY. Del U del capital X will give you 1. Del U del capital Y is equal to, it will be equal to A. Therefore, in this case, what is capital P? Capital P, we have it as del set del capital X, but we can write it as del set del U into del U del capital X. Del U del capital X is 1, so it will reduce to del set del U. And what is capital Q? It is capital Q is this one, del set del capital Y. So write it del set del capital Y, and this can be written as del set del U into del U del Y. Now what is del U del Y? Del U del Y is equal to A. So this will be A into del set del U. Now see, what is P? It is del set del U, and Q is also A times of the same thing, del set del U. So it reduces to an ordinary partial differential equation. So you put this one now. You put del set del U is equal to d set du. Therefore, what is capital P now? It will be just d set du, and capital Q is equal to A d set du. Therefore, this last equation, this equation, I can substitute the value of P and Q in this equation 3. Therefore, equation 3 now, or not equation 3, let me keep this one as equation 4, this one. Substituting the value of capital P and Q now by this one in equation 4. Therefore, equation 4 now will implies you P cubed, it is d set du into what is cubed? It is A d set du. A d set du is equal to set square. Now, this will implies that d set du, the whole square into A, is equal to set square, because d set du into d set du will become the whole square. Now, this will implies that d set du, the whole square is equal to set square by A. Now take the positive square root of this one, so you'll get it as d set du is equal to set by A. Now you can separate the variables. Now you can bring across multiply this set to this side, so you can write as d set by set is equal to A du. Now, which can be easily integrated. So what is the integral of d set by set is equal to A du? It will be log set is equal to A u plus some constant, say, let me keep it as k. or log set is equal to A into what is U? It is that capital X plus A capital Y plus K. But what we have here is that capital X is equal to what? From equation 1. Capital X is equal to x to the power 5 by 5 and capital Y is y to the power 4 by 4. So let us replace back this one now. It will be log set is equal to A into x to the power 5 by 5 plus A into y, it is y to the power 4 by 4 from equation 2. Y to the power 4 by 4 plus k. You can write from 1 and 2. So this is the required solution of the given equation p cubed is equal to x to the power 4 y cubed into z square. So this one you can reduce it to standard 3 and then follow the steps that I have done mentioned in the theory part. Then you'll be able to get the required solution of this equation p cubed is equal to x to the power 4 y cubed z square. Hope it is clear. And I'll send the notes also and some more solved problems in the Google Classroom.